Okay, today is January the 9th, 2016. We're watching the Northeast Pacific water vapor loop. We're watching a storm right here as it advances towards the west coast. This is a 967 millibar storm right here, and obviously it's being hit by a HARP transmitter. We can see a whole lot of dark air right in here in the middle of this system. And also we have another area up here which is partially spinning clockwise. There's a transmitter right here, and so this entire core has been disrupted, and parts of that are moving in a clockwise manner right here. We've got a HARP transmitter over here hitting the next system moving in from the Bering Sea, and we have high pressure developing all up and down the west coast. We can see that happening right here and all through here. And Tropical Storm Pali over here has diminished to, I think, 45-mile-per-hour winds and has moved to the west. This was originally forecast. It was moving in a northwest direction, but that was that never really happened. This storm is way out over here now in the Central Pacific. All right, let's take a look at some of these other maps, and we can see this front moving towards the west coast and high pressure developing. Where I am in the Central Coast area today, we had very light rain. It was actually just really a heavy dew last night and yesterday and last night and today. There was actually a heavy rain forecast for the Central Coast area, San Luis Obispo, all the way down to Santa Barbara, but it just never really got going. Here's the jet stream map showing what's happening here. We have a disruption right in here where that HARP transmitter is. We do have some high-speed flow through California, and that storm front is actually following this path up into Canada. This storm right here, that 967 millibar. Okay, let's take a look now at the, this is the western water vapor loop. We can see the size of this storm. It's very large, big moisture field, and we can see high pressure developing in. There are high pressure zones being positioned all up and down the west coast. We'll look at that on the pressure maps. So this is going to probably be blocked. Most of it will be blocked. Again, there was not much rain. We saw chemtrails on the central coast yesterday near from Lompoc all the way down to Santa Barbara. There were chemtrails in the skies, and that stopped most of the rain. And the same story today. We did get a little bit of rain, but nothing measurable. All right. Okay, so let's go on to the next map. And we can see that dry air mass right in here where they're installing that high pressure. And this is interesting right here. Look at this yellow moisture field moving into Southern California. It just disappears once it hits the mainland border right there. Once it moves, it didn't even get onshore. It just seems to evaporate as it moves down. Yeah, everything just, it's almost like the coastline cuts everything off right here where the pen tip is as it moves in. The entire top of that moisture field right here is just disappears. All right, let's carry on here to the next map. This is the Central Pacific. This is Hawaii. And Pali, Tropical Storm Pali, is now, I believe it's 45 miles per hour winds. And this system, instead of moving north-northwest, it's moved to the, it's moved pretty much due west. And they've been hitting this, and we can see some evidence of that, some pressure waves in these views here. We'll take a look at that. There's a, right here, there's a pressure wave, blast wave from the, they heat the core of these storms with either microwave or possibly laser. Personally, I believe it's a microwave since water vapor reacts to specific microwave frequencies. There's much more efficient absorption of the water vapor, or rather of the microwaves at certain frequencies. So I believe that they're using microwaves to do this work. All right, let's take a look now at the the rainbow loop, and we can see down here that this area here is being targeted, and also in the visible light mode. We'll take a look at that. But right here, in this last couple of frames, you can see that blast ring right there, and that's where they superheat the core of this storm with microwave, and of course the rapid expansion of the water vapor creates these rings, these blast rings, these pressure rings, and also will generate a blast pattern. And we're seeing both actually right now. So let's go take a look now at the visible loop, and on the last frame, which I already have frozen here, let's just run the loop, and we can see what happens on the last two frames. We see a dimple, and as time advances here in a few minutes, or rather in a couple hours, we'll get to see more of what occurs after that dimple. We'll get a blast ring that moves out. But there's a dimple there. We'll stop this thing and scroll through it. Okay, right there. I'm using a different monitor tonight, so I apologize for the crappy resolution, but we can see right there as I go back and forth between these two frames, we can see the dimple right there. It looks like a little pock mark right there. And as we go forward one frame, we see that there's a ring right there that moves out radially from that point. Now this is where they hit the thunderstorm with the transmitter microwave right here, and that superheats the core and disrupts the organization of the system. And that's how they're doing this. And I believe they're using microwaves. It's certainly possible to use microwave, satellite-based, and also laser. But I think that microwave would be a better tool because you can tailor the power output. You can also pick the right frequencies that'll be fully absorbed by the water vapor, and you won't have, if you got ships down under here, you don't want to be shooting lasers at them. That's another discussion for another time. But at any rate, laser or microwave, they're getting the job done, and that's the main thing. All right, let's go on to the next map. This is Central Pacific Hurricane Center. We can see that Pali is now at 40 miles per hour maximum sustained winds, 1,000 millibar pressure, and moving due west at 2 miles per hour. So the storm never really moved north as they had predicted, and got into the jet stream. They prevented that, so it never did move north as forecasted. All right, let's go on to the let's go take a look at the surface pressure analysis map. Surface analysis map, and we can see that the storm moving towards California and the west coast is a 967 millibar storm, and we have another low right just to the north of that, a developing storm of 976 millibar. That's forecast to move up to the north, and that's the same story with this one here. Got a big cold front. This is the HARP transmitter right here. Let's go take a look at the big map again. That big warm front is actually all this being installed here. This is man-made high pressure from a HARP transmitter to block this system as it moves towards California. We can see that filling in. That's descending air causing that. Okay, let's go back to the... There's a lot going on out here. We have a lot of lows, but mainly look at all the highs off of California all the way up through Canada, and this is high pressure to block all this weather moving in to the west coast. So that's going to block a lot of the stormy weather. And next we have the wave analysis. This is the ocean swell analysis. We've got that storm we were just looking at. It's generating 38 and 40 foot seas right in the core. Okay, so we'll keep an eye on that. So that's the summary for today, January 9th, and we will do another update tomorrow. All right, that's it.